Well, there was one other thing you did in the discussion. I asked you to take two lines that were parallel and then reflect over line L and then over line M and talk about what happens with that. And if you did that just right, you probably figured out that by reflection, those are congruent, and by reflection, those are congruent. So this total distance is twice this distance, and it's along the same vector because these lines are perpendicular to parallel lines. And so this is a translation. A translation is a composition of two reflections across lines that admit a common perpendicular. By the way, why is it phrased that way? Why do we phrase it across lines that admit a common perpendicular instead of just saying across two parallel lines? That's something to think about. The translation theorem says if P is any point on the line K, then P prime is the translation of P, where P in P prime, the translation of P along vector AB is the point on K such that PP prime is AB and ray PP prime is equivalent to ray AB. If P is any point not on K, then its image is on the same side of K as P. We should note if N is any line perpendicular to K, then there exist these other lines S and T such that this does the job for us. This is your Euclidean understanding of translations. And again, there's a nice little part of the theorem that says, yeah, using these two lines are great, but using any two lines that are this far apart will do great. We could have put L and M way out here. We could have put L and M on this side of P. It doesn't matter. If you reflect over this one first and that one second, this one first and that one second, this one first and that one second, P double prime is right there. It does not matter where these lines are in the plane. It matters that they are along this, it matters that the vector between them looks like that. That's what matters. And it does not matter where those lines are, It matters, and I shouldn't use red because I used red over there. It matters that this is the vector going from one line to the other. And so you give me any line in the plane that's perpendicular to K, and there is another line in the plane that completes the job. And we'll use that in later theorems. Okay, so we've got the basic building blocks. Where do we go from here? That remains to be seen. But this is a good intro.